In this lesson, we're going to go over how to solve separable differential equations. We're also going to talk about how we can find the particular solution of a differential equation given an initial condition. So before we can actually solve a differential equation, we want to talk about the technique we're going to use, and that's called separation of variables. So basically, it's what it sounds like. We're trying to separate the variables. So any y's we want to get together, any x's we want to get together. So the same variables we want to get on the same side. So here we have a differential equation. We have dy over dx equals g of x times f of y. Right? It's a differential equation because we have a derivative. And the dy over dx is equal to two different functions, one in terms of x and one in terms of y. So this is just like a basic generic example. So what I want to do, my goal, is to get the f of y and the dy on the same side and the g of x and the dx on the same side. So I would have to divide by f of y. Right? Remember when I divide by f of y, it's the same thing as multiplying by 1 over f of y. So I'm dividing out the f of y on the right, and I'm dividing it on the left, but really multiplying by 1 over it. And to get rid of the dx in the bottom, I would multiply dx on the left to cancel out the dx, and I have multiplied also on the right-hand side. So what I end up with is 1 over f of y dy equals g of x dx. So now I've successfully separated the variables. Okay, so we're going to use this technique to actually solve these differential equations. So let's look at this first example. We want to solve the differential equation, this one. So first thing I'm going to do is separate the variables. So I have to divide the y squared, and I have to multiply the dx. So when I divide by y squared, I'm going to have 1 over y squared dy equals negative 4x dx. So I just did the same method that I did in the previous slide. Instead of showing the actual division, I'm just dividing it to the left and then the dx multiplying it to the right. Okay, so from here, I'm just going to rewrite it a little bit so that way I have something a little bit easier to work with. So instead of 1 over y squared, I'm just going to rewrite that as y to the negative 2 dy, and that's equal to negative 4x dx. So what I'm going to do here is I'm trying to solve this. So that means I'm trying to solve for y. I want a y equals equation. So I'm going to take the integral of both sides. So take the integral, take the integral. When I take the integral, I'm doing the antiderivative. So y to the negative 2, I'm going to use the reverse power rule. So I'll increase my exponent by 1 and then divide by that new exponent. So I have negative y to the negative 1. And then I have the antiderivative of negative 4x is going to be negative 2x squared. Now, since this is an indefinite integral, I have to include that plus c. Now, technically, there's going to be a plus c with the y and a plus c with the x because I'm taking the antiderivative of both. But because I have a constant, I can move constants around, and my result is always going to be a constant. It doesn't matter what it is, but it's always going to be some constant. So I'm only going to use it once, and I'm going to put it on the right here with the x. Okay, so technically, again, there would be a plus c on both sides, but when I move one constant to the other side, it's still going to be a constant. So our main idea here is to get the y by itself. So I'm going to attach the plus c to the x. Okay, so from here, I'm just going to rewrite this as negative 1 over y, and that's equal to negative 2x squared plus c. So I want to get y by itself, so I'm going to just solve for y. So I can multiply both sides by y and then divide by this negative 2x squared plus c. So I'll get negative 1 equals negative 2x squared plus c. And I'm going to put this in parentheses times y. And then what I'm going to do is divide by negative 2x squared plus c. Divide by negative 2x squared plus c. So I end up with my equation, y equals negative 1 over negative 2x squared plus c. And that would be my solution to the differential equation. So let's look at another example. So again, we want to solve the differential equation. So here on the right-hand side, I have two y's. So before I do anything with separating the variables, I'm going to factor that out. So I'm going to take out the common factor of y. So I'm left with 1 plus x. So from here, now I'm going to separate the variables. So I'm going to divide both sides by y and multiply both sides by dx. So I would get 1 over y dy, and that's equal to 1 plus x dx. Okay, so from here, I'm going to take the integral of both sides. When I take the integral of 1 over y, that's going to be ln, absolute value of y. And then the integral of 1 plus x is going to be x plus 1 half x squared. And then again, I'm going to do plus c because it's an indefinite integral. So from here, I'm trying to solve for y. I need to get y by itself. So what I have to do is change this to an exponential. So remember that the base of an ln is e. So I'm going to have e to the x plus 1 half x squared plus c equals y. Okay, notice that I did drop the absolute value bars because when I raise something to a power, I can't get a negative value. So the y would be positive. So this looks kind of ugly. Like I could leave this, I guess, as an answer, but let's simplify it a little bit. So when we have exponents that are being added together, we know that that means that if I have the same base and I'm multiplying, that's how the exponents get added together. So I'm going to break this up, and I'm going to put the y on this side because I like to do that. So e to the x times e to the 1 half x squared times e to the c. If I multiply these all together, that's the same thing as e to the x plus 1 half x squared plus c. Okay, the reason that I'm kind of doing this is to get the c out of the exponent right now. So e to the c, if I raise e to a constant, it's going to be some constant because e is a constant. So I'm raising a constant to a constant, so I get some constant number. So that is just going to be c. So I'm going to call that c. So what I'm going to do here to kind of simplify my answer is I'm going to put the c in the front, and then I'm going to take these two e's and multiply them together again. So I'm going to get e to the x plus 1 half x squared. And then this would be my answer. Okay, so now we're going to take it one step further. We have to solve this differential equation, but now we're actually going to try to find a particular solution. So the two previous examples before this, we had C in our answer. That's your generic or general solution because it's not specific to a certain function. So now we have more information, so we're going to use that to help us find the particular solution. So first thing we want to do is we want to find the general solution. So just like before, we're going to use separation of variables, and we're going to solve for y. So I'm going to multiply both sides by y, multiply both sides by dx. So I'll get y dy equals negative x dx. So now I'm going to take the antiderivative by taking the integral. So this is going to give me 1 half y squared equals negative 1 half x squared plus c. We're trying to solve for y, so I'm going to multiply both sides by 2. So this will be y squared equals, when I multiply this side by 2, 2 times negative a half, that's going to give me negative x squared. And then when I multiply 2 times c, again, 2 times a constant is just going to be some constant. So I'm going to just keep that as plus c. And then I take the square root. So when we take the square root, remember that we do get plus or minus. So plus or minus the square root of negative x squared plus c. So that is my general solution. So now part A says solve for y that goes through 4, 3. So what's the equation of the line that goes through 4, 3? So we're going to plug that in for x and for y. But the first thing we have to figure out is what quadrant this is, because we have this plus or minus, so we're not going to use both the plus and the minus. 4, 3 is in the first quadrant, so that means that our square root is going to be positive. So we're going to use our generic function as positive square root of negative x squared plus c. Okay, so I'm only taking the positive version here. So now I'm going to plug in the points. So I'm going to plug in 3 for y. Oops, that's not how you draw a 3. Plug in 3 equals square root of negative, I'm going to plug in 4 for x plus c. Okay, so this is going to give me 3 equals the square root of negative 16 plus c. I'm going to square both sides to get rid of the square root. So I have 9 equals negative 16 plus c. So I end up getting c is equal to 25. So my particular solution here would be that y is equal to the square root of negative x squared plus 25. Okay, then we're going to do the same thing through a different point. So now we're going to look at 3, negative 1. So 3, negative 1 is in the fourth quadrant. So that means that my square root is going to be negative. So my general solution that I'm using is negative square root of negative x squared plus c. And then from here, I'm going to plug in the point. So for y, I plug in negative 1. And then I have negative square root of negative 3 squared plus c. And again, I'm going to square both sides. So when I square negative 1, I get 1. When I square the right-hand side, this negative will go away and become positive. And then I have on the inside here, negative 9 plus c. So when I solve for c, I get that c is equal to 10. So my particular solution here would be y is equal to negative square root of negative x squared plus 10. Okay. So find a curve in the xy plane that passes through 0, 3 and whose tangent line at a point xy has slope 2x over y squared. So here they didn't give us a differential equation. They didn't say dy over dx equals something. But knowing that dy over dx is slope, we can figure it out ourselves. So we're going to set it up and say dy over dx, because that's the slope, and the slope is equal to 2x over y squared. So what we're trying to do here is find a curve that goes through that point and uses this differential equation. So just like before, we're going to separate the variables. I'm going to multiply both sides by y squared and multiply both sides by dx. So I'm going to get y squared dy, and that's equal to 2x dx. Take the antiderivative of them. So this is going to give me 1/3 y to the third equals x squared plus c. Okay, I'm going to multiply both sides by 3. So I'm going to get y cubed equals 3x squared. And then 3 times c is just going to be c. And then I have to take the cube root. So y equals the cubed root of 3x squared plus c. So that's my general solution. And it has to pass through the point 0, 3. So we're going to plug in 3 for y. And then I have the cubed root of 3 times 0 for x squared plus c. So we'll get that 3 equals the cubed root of c. So I have to cube both sides. And I end up with 27 equals c. So our particular solution here is going to be y equals the cubed root of 3x squared plus 27. And we'll look at one more example. So again, solve the differential equation with the initial condition that when x is 3, y is 1/4. So when I look at my differential equation, I need to divide both sides by y squared and multiply both sides by dx. So I'm going to get 1 over y squared dy, and that's going to be equal to 6 minus 2x dx. So I'm going to take the antiderivative. So when I do that, I'm going to get negative 1 over y equals 6x minus x squared plus c. So I want to solve for y. So I'm going to multiply y and then divide by this equation. So I'm just going to end up with y equals negative 1 over 6x minus x squared plus c. So that's my generic equation. And then they give us the initial condition. So I'll plug in 1/4 goes in place of y equals negative 1 over, and I'll plug in 3 for x. So I'm going to get 6 times 3 minus, I'm just going to put 9 there, plus c. So we get negative 1 over 18 minus 9, so 9 plus c. And then I'm going to cross multiply. So 9 plus c is equal to negative 4. So c is equal to negative 13. So then our particular solution here would be y equals negative 1 over 6x minus x squared minus 13.